In May 2026, the digital wallet held by the pseudonymous user at CPRKRN had become a $400,000 monument to a forgotten password. 5 Bitcoin had sat dormant in this account for 11 years, appreciating in value while remaining completely inaccessible to the person who owned them. These funds were originally purchased in 2015 for about $1,250. Shortly after the transaction, the user created a highly complex, idiosyncratic password while in a drug-induced state. Upon waking, the credentials were gone from their memory, and the idiosyncratic string of characters became a permanent barrier to their wealth. Over the next decade, the recovery efforts grew increasingly desperate. The user rented specialized GPU clusters to run massive brute force attacks, testing over 7 trillion password combinations. They even hired professional digital forensics firms, but every specialized service and hardware cluster failed to produce a result. The blockade was built on standard cryptographic hardening. The wallet used AES-128 encryption combined with PBKDF2, a function designed specifically to throttle the speed of computational guessing. This made traditional dictionary attacks and hardware-based brute forcing mathematically infeasible, regardless of the processing power applied. Prior to the intervention of artificial intelligence, these types of non-custodial lockouts were considered permanent. Mathematics simply outlasted human memory, leaving the assets trapped in a state of digital limbo. This chart shows the scale of the lost Bitcoin problem. Currently, between 11% and 19% of the total global supply is estimated to be dormant or unrecoverable. That represents up to 4 million coins that may never move again. Every day, roughly 566 Bitcoin transition into the ancient category, having remained untouched for over a decade. This rate of dormancy actually exceeds the 450 new coins produced daily through mining, which creates a continuous structural reduction in the available supply. If AI-assisted forensics can begin to recover even a small portion of these 4 million coins, tens of billions of dollars in previously illiquid capital would suddenly re-enter the market. This could fundamentally shift the asset scarcity model and introduce massive downward pressure on current prices. In a final attempt to recover the funds, the user gathered over a gigabyte of unstructured digital history, including old hard drive backups, Apple Notes, and years of email archives. They uploaded this entire repository of personal data into Anthropic's Claude AI, hoping the model could find a clue they had missed. Large language models can identify patterns and context that traditional search algorithms overlook. While a standard search requires an exact keyword match, Claude parsed deprecated file formats, recognizing the structural significance of wallet backups over half a decade old. After analyzing the data, Claude isolated a specific wallet.dat file from December 2019. The AI recognized that this specific backup was created before the user's subsequent password changes, making it the missing link in the recovery process. This file allowed the user to match a handwritten mnemonic phrase they had found in an old notebook with the correct cryptographic structure. However, even with the right file and the right phrase, the recovery software they were using still wouldn't work. The user was using an open-source recovery script called BTC Recover. As shown here, the script requires 2 primary inputs to generate the decryption private key, a variable called the shared key and the user's password. For the decryption to work, the software has to combine or concatenate these 2 values in a precise sequence. This specific string is then hashed to produce the final credentials needed to access the wallet. Claude analyzed the script's code and discovered a subtle logic error. The software was programmed to concatenate these values in the reverse order, placing the password before the shared key. Because cryptographic hashing is sensitive to input sequence, this reversed order ensured that even the correct password would fail every time the script was run. Claude corrected the Python script, ensuring the variables were merged in the sequence required by the 2019-era wallet architecture. On the very first try with the modified code, the private keys were successfully decrypted, and the 5 Bitcoin were finally moved to a new address. Claude bypassed the encryption by diagnosing a logic error in the recovery utilities code. The AI functioned as an automated software engineer, identifying and repairing a technical flaw that had made the user's valid credentials appear incorrect for years. The same analytical capability used to recover a crypto wallet was simultaneously being deployed against some of the world's most secure software architectures. In mid-May 2026, researchers used Anthropic's Mythos AI to scan Apple's macOS. By chaining together several minor bugs that human engineers have missed, the AI autonomously engineered a kernel memory corruption exploit, compromising the security of Apple's advanced M5 silicon. This was part of a broader surge in vulnerabilities, from the Fragnesia Linux kernel exploit to the rise of automated scam networks generating billions of spam calls monthly. AI-driven discovery is rapidly identifying flaws across the entire global technology stack. These efficiency gains have also come with a severe human cost. Over 92,000 tech workers were laid off in the first half of 2026. Companies like Snap have reduced their workforce significantly, noting that AI agents now generate more than 65% of the company's software code. AI now operates at both ends of the security spectrum. It can fortify a codebase against known threats, while simultaneously discovering vulnerabilities that have existed for years. It has become a tool for both total defense and absolute discovery. Sustaining this level of computation is placing unprecedented strain on physical infrastructure. NVIDIA CEO Jensen Huang recently warned that the exponential growth of AI data centers is creating an energy demand shock that the current electricity grid was never designed to handle. Beyond the physical toll, the recovery of these lost Bitcoin highlights a new risk to personal security. To access the funds, the user had to upload an entire gigabyte of their most sensitive digital history, including years of private messages and financial archives, to a centralized corporate cloud. Accessing these dormant assets required the total surrender of a decade's worth of personal correspondence and digital artifacts to a third-party database. We have reached a point where the only way to fix our past mistakes is to permanently relinquish the privacy of our digital history, a trade-off that leaves our digital footprint permanently exposed.